Hello boys and girls, welcome back to another edition of Geometry Excellence on the EOC television. Okay, what are we going to do today? Well, we're given a right triangle. Okay, I can do that. We're going to solve for missing side lengths by using ratios of special right triangles 45, 45, 90. Ooh, and this is honors only. Ooh, this one's a special one for special right triangles. Okay, check it out. 45, 45, 90 is a magical triangle. That's one thing you got to know. It's magic. 30, 60, 90 is also magic. We're going to go over that next time. So, all triangles with an angle measure of 45, 45, and 90 are similar because of angle. And you can put another angle right there if you want, but it's just two angles are congruent, so therefore the third angle is congruent also. So we got that. So this is what we need. Let's draw a picture. Whoop! Here's a right triangle, and it is going to be isosceles because we have two equal angles, therefore we have two equal sides. Okay? So what is a 45, 45, 90 magical triangle look like? Well, it has x here. If this is x, this also is x because it's the same length. This is 5, that's 5, that's 10, that's 10. And then my hypotenuse, which is right across from the right angle, is x radical 2. Sorry, not radical x, radical 2. So, what does that mean? Let's draw a sample one, okay? Let's put some numbers to it. Okay, so we have two congruent sides, two congruent angles. This is an isosceles right triangle. You can classify it. And let's say we have, I don't know, 10. If we have 10 here, this side is also 10, and therefore 10 is going to be the x, and so I put it right in front and multiply it by radical 2. So that is an example of one with numbers, and here's one x radical 2 with the variables, okay? Let's see if we can apply on some ejemplos, some examples. Okay, check it out right here. So 45, 45, 90. So I know that x radical 2. That is my pattern. Here's 45, 45, 90. So I'm going to draw that off to the side. So I'm going to use that as a reference. So I have here, these are the two congruent sides because of 45, 45. And so therefore x is going to be 3. So x is 3. Y, 3, 3 is going to be, I'm going to take my side lengths and it's going to be, 3 radical 2. Right here. 3 radical 2. Easy. It's a magical. So, what we got now? Over here. So now given the hypotenuse, this side is 45, this side is also 45, which means that these two sides are congruent. Okay. So that would mean x is 3 and y is also 3. I don't know why it says x and y. It's just, could say x and x. It doesn't matter because it's the same. Okay, we got that. That at least seems pretty easy. We just follow the pattern. Okay, let's try another one. Alright, so we got this. I'm going to draw my little picture off to the side. Isosceles, 45, 45, x radical 2. The more I write it, the more I remember it, because it's going to get a little tricky in a second. So this is 5 radical 2. What are x and y? Ready, set, pause the video. What do you got? Yeah, you're right. They're both 5 radical 2. Okay, now let's do a trickier one. Here we go. Right over here on the right. Check it out. So now, look at that. The leg, these are congruent. So this is 45 and this is 45, these two angles. So the leg is 5 radical 2. So the leg right here is 5 radical 2. Ooh, so that would mean the other leg is also 5 radical 2, that y over there. I got it. And so now what the heck is the hypotenuse? Man, I don't know. Well, the hypotenuse here, so whatever I get here, I need to multiply it by radical 2. So whatever the leg is, so that's 5 radical 2, that's x times radical 2. Woo! Okay. So just like here is 5, and then I put 5 times radical 2. This is 5 radical 2 times radical 2. Okay. So now, what is radical 2 times radical 2? Let's break it down for a second. Check it out. So what would be radical 9 times radical 9? Well, radical 9 is 3, right? 3 times 3, so that is 9. Ooh! So radical 9 times radical 9 is 9. Ooh, you seeing a pattern? Let's do another one. Check this out. What's radical 4 times radical 4? Well, that's 2, because square root of 4 is 2, times 2, that's 4. So radical 4 times radical 4 is 4. Ooh. So if radical 9 times radical 9 is 9, radical 4 times radical 4 is 4, radical 2 times radical 2 is? Yeah, it's 2. So this is a 5, and radical 2 times radical 2 is 2. It's like radical 10 times radical 10 is 10. Radical a million times radical million is a million. So 5 times 2 is 10. There you go. So that's my hypotenuse. Got it. Okay. Two more. Okay. So this one right here. Draw this in your notebook. Draw this in your notebook. So I have x radical 2. Draw my little reference every single time just to help myself. Okay, so now the hypotenuse is 9. It doesn't have a radical next to it. Woo! Oh man, what are we going to do now? Well, I need to get these two congruent sides. So x and y are congruent, so if I get x, I can get y. It's the same thing. So I need x first. So I know that 9 is my hypotenuse is this. So that equals x radical 2. And so I can solve for the x here. Check this out. So I'm going to divide by radical 2. Divide by radical 2. And so I have x, I can write it the other way, equals 9 divided by radical 2. Now we have a little dilemma because you can't have a radical in the denominator. It's like bad grammar. It's like a double negative. You can't do that. And so what you do is you need to multiply it by a factor of 1. And that factor of 1 you just get from the denominator. So that's radical 2 times radical 2. Like if radical 5 were in the denominator, I multiply by radical 5 over radical 5. Okay, so numerator, 9 times radical 2 is 9 radical 2. Radical 2 times radical 2, we just did that, is 2. Like radical 10 times radical 10 is 10, or radical 9 times radical 9 is 9. There you go. So that is going to be my leg. Whoop. 9 radical 2 over 2 divided by 2, and 9 radical 2 divided by 2. Got it. One more. We're almost there. Okay, so now, same thing. Whoop, 12 is my hypotenuse. So this one is just like this. So these two are about the same. So let's see if you can do it. Whoop. Pause the video, see if you can get these two legs based upon this one we just did. Ready, set, go. Alright, let's see what we got. Check it out. So this 12 is going to be x radical 2. So that's what I'm solving for. So I'm going to divide by radical 2. And so I have 12 divided by radical 2 is x. Now I can't have a radical on the denominator, so I'm going to multiply by radical 2 over radical 2. And I get 12 radical 2 over 2. You get that? Well, there's one more step. What is it? Oh, 12 divided by 2. What's that? Yeah, it's 6. So the answer is 6 radical 2. So 6 radical 2 here and 6 radical 2 there. Got it. All right, looking good. Last but not least, we have some problems you got to do on your own. So here we go. Let's practice these right now. So you have some. Pause the video. Practice these. Raise your hand if you have any questions. Great job.